Well, don't walk in front of my camera.
It's powerful.
Another day.
Okay.
I can't believe she wakes up and is like, I don't want to come to school. And her parents
That's
are
how you
like,
know
okay.
she's spoiled.
My mom would be like, nope, get up. I don't care. She's
Mom's
like,
like, I'm paying this much money for you to come to school.
Okie dokie. Let's get started. I only have like a half a period of lecture, and then we're gonna play a Kahoot. So first, I want to go over Schoology. I think this is probably more. I don't see you guys having a lot of issues with it, but just in case you are, I want to point out where everything is at. So this is what the course looks like for Ash. I'm not going to go to the grades tab. So you sign in. This is how it looks. Class intro and resources should have like a welcome letter, the syllabus, and the getting to know you questions. You can access all the digital copy of the doodle notes, the things that I handed out to you guys here. So if you lose them or want to print out a new one, you don't like your coloring, go ahead and do that. I have pictures from our lab on Wednesday, but the meat and potatoes of the material is under the first quarter physical science. Just keep doing the drop downs until you get to the chapter you want. And I have converted all of my PowerPoints, or I plan on doing all the chapter 1 PowerPoints as well. But for chapter 2, I converted all my PowerPoints to Google Slides. So if I make an edit to them, it'll automatically update here. It's a little easier to read. Yes, ma'am.
can we take a photo?
On your own.
Oh,
Yeah.
for that.
So if you click on the teaching slides, so right here where it says chapter 2B, those are my teaching slides, okay? If it has a link, and then the chapter 2B, 2C, 2 whatever. Chapter 2 SE is a student edition text. So if you don't have a textbook or don't have it with you, you can always find the digital copy of it here. There's a link to the Kahoot. You can play on your own. We're going to play the challenge version in class. These are your section review questions and the extra credit if you're not in honors. So anything that you need for class is right here. And I'm not sure if anyone is seeing these updates, but I've been posting information here. There's a link to the class YouTube channel. So if you miss class or just want to rewatch the class for information,
How many likes do we have?
we have 0 likes. We only have 9 views so far, y'all.
All right,
So,
that's us.
Go ahead and you can subscribe if you want. So all my lectures are going to be posted here. So if you miss class, this gives you an opportunity to watch without having to come see me afterwards. So anywho, that's our class YouTube channel. Any other updates that I post, like video newsletters? Video newsletters are here. I might add those to the class YouTube channel as well. So
I tried to touch one of the videos, and it took me to like this thing because I was on the school thing.
okay.
And it tells me the video was not approved.
Oh, okay. Well,
is approved by VBA.
Yeah.
what I will do
I said,
instead.
like, Christ alone is not
For
approved.
real, that's what
Yeah.
I looked. I was like, okay, I'm gonna look at this Christian.
Okay, so I'm going to post these video newsletters to the YouTube channel as well until I get sick of doing video newsletters, and then I'll just type it out.
I can do it for you.
A video newsletter? Okay. Let's do
I'll
that.
be amazing at
All right, so let's get to class materials. So I'm going to open up first quarter, unit 1, chapter 2.
It's gonna be a lot of chapters.
All right, chapter 2B. So this is what it will look like for you. It'll be a little bit easier to read than those PowerPoints I was uploading if you had been using those. So present. All right, I want
So
to
fancy.
share this tab instead.
Thank you.
Okay. I think that's what we need to do. I hope that is sharing to the right tab. Okay, so we're talking about, yesterday we talked about what matter is, how we measure it. We talked about the difference between mass and density and volume and weight. Today we're just going to talk about how we classify matter. So our essential questions are, how are mixtures different from pure substances? How can I recognize a pure substance? And how can I recognize mixtures? So we've got 2 worksheets that we're going over today. It's going to be the one that says, somebody in the first period took it. It's the one that says elements, compounds, mixtures, and then this one as well, the mixtures worksheet. Okay, so why do we even bother classifying matter? Classification systems provide a structure within which we can conduct scientific studies, blah, blah, blah. Simply put, classification enables us to do science. Yes, that one. So how do we classify matter? We classify it based on its properties, its qualities, its characteristics. So first we have to start with kind of the base term here. So we have pure substances that are made of a material made of only one kind of element or a compound. They're not a mixture. A pure substance may be either an element or a compound. Okay? So that's just definition for you. We're going to focus mostly on definitions today. Pure substance is a material made of only one kind of element or compound, not a mixture. Okay. So two principal ways of classifying matter are according to its physical state, whether it's a solid, a liquid, or a gas, and its composition, whether it's an element, a compound, or a mixture. So you could have a liquid element, you could have a gas mixture, you could have a solid compound. Okay. First, we have elements. Elements contain only one type of atom. Okay. They cannot be broken down into any simpler substance by either chemical or physical means and can exist as either atoms or molecules. So in this example, we have oxygen. We have an oxygen atom, like O by itself, and we also have oxygen as an O2 molecule, okay? But water would not be an element because it has more than one type of atom. It has hydrogen and oxygen atoms. So you can't break that down into any type of simpler substance here. All right. I am going to the next slide. Okay. There's a little lag. All right, so these are some picture examples of what an element is. So let's look at these pictures first. So imagine this as an atom, okay? A little purple circle or a green triangle. An atom by itself is an element. An atom combined to itself is a molecule. But these are also, or an atom, these are all examples of elements. So in a chemical form, sodium, oxygen, boron, hydrogen, okay, they can be bonded to themselves to make molecules, or they can just be on their own. So those are examples of elements. All right, compounds contain atoms of two or more different elements bonded together in a specific ratio. So I want you to think of water here. Okay. They can be broken down into simpler substances, elements, by chemical means, but not by physical means. And they have different properties than their component elements. So let's think about water here. They contain atoms of two or more different elements. So we have two different elements in here. We have hydrogen and oxygen, and they are bonded together in a specific ratio. So for every 2 hydrogen, we have 1 oxygen. That's our ratio every time, or for no matter what quantity of water we have. And they can be broken down into simpler substances. It can break apart the hydrogen from the oxygen, but only by chemical means, not by physical means. Because they're sharing electrons, you have to break that electron, that chemical bond, in order to break it apart. You don't physically pull apart water. That's not how that works. And compounds have different properties than its component elements. So hydrogen has its own qualities and characteristics. Oxygen has totally different qualities and characteristics, but when they're combined, they make something completely different. All right, so that's what that means. All right, these are examples of compounds, oxygen, salt, sugar. Okay, they always exist in these ratios. So when you have a salt compound, it's always 1 sodium to 1 chloride or chlorine. For water, it's always 2 hydrogen for every oxygen. For sugar, it's always 6 carbon, 12 hydrogens, 6 oxygens. Okay, and then in picture form, it looks like that. So these are 2 different types of atoms that are bonded together. If they're not chemically bonded together, then they would be floating separated from each other. Mixtures are a third type. So mixtures contain 2 or more substances, elements, or compounds that are not bonded together. They can be separated physically because they're not chemically bonded together, and they retain many of the same properties of their components. So I'll copy this down. On the next slide, it'll make a little more sense. Okie dokie. Sorry, in 2 slides it'll make more sense. So when mixtures, we have 2 different types of mixtures. We have homogeneous mixtures and we have heterogeneous mixtures. Homogeneous mixtures are mixtures in which substances are evenly distributed and have a uniform composition, whereas heterogeneous mixtures are mixtures in which substances are not evenly distributed and the original substances are physically distinct. So I want you to think about, let's compare salt water with salad here, okay? We have salt water, which is a homogeneous solution. The salt and the water are not chemically bonded together. You can physically separate them by applying temperature, letting the water evaporate, you're left with salt. That tells us it's not chemically bonded together. You can, but within that solution, within that homogeneous mixture, the substances are evenly distributed. Heterogeneous, I want you to think about as salad, okay? So mixtures in which substances are not evenly distributed. So your substances are lettuce, tomato, croutons, cheese. They can be like your tomatoes, because they're heavier, they usually sink to the bottom, whereas the cheese kind of like floats out the top. So the original substances are physically distinct. You can still look at it and tell what everything is. Okay, you don't look at salt water and see, oh, I see the salt and I see the water. It's all mixed evenly together. Does that make sense to everybody? Okay. All right, so mixtures again, a salad, a pizza, air. Air is a mixture. So in this example, you have 2 different types of compounds that are within the same space, but they're not chemically bonded together. Okay. Here you have a compound and an element. Here you just have elements, but they're not chemically bonded together. All right, so how do we know that water is not simply a mixture of hydrogen and oxygen? Go back to the definition of a mixture compared to the definition of a compound. The main difference is that a compound is elements that are chemically bonded together. A mixture is where they're physically together, but they're not chemically bound together. So if hydrogen and oxygen, both being gases, were just physically mixed together, you wouldn't have water, okay? Because they mixed, they created a substance that had totally different properties than the 2 original substances. So if you just mix the 2 gases together, you wouldn't be able to tell. Okay, you'd be able to physically separate them, but because of the change of characteristics that we see when hydrogen and oxygen combine, we know that there was a chemical change that occurred, and that there's chemical bonds that have created a new substance. And it's not just a mixture. So oxygen and hydrogen are both gases that are chemically bonded to create water. They cannot be separated physically. Sorry, I probably should put that up right away. Okay, I am moving on. All right, so again, if you go to, this is a different worksheet now, this is a mixtures worksheet. Mixtures are a combination of substances that can be separated by physical means. Okay, so we're just reiterating that definition of what a mixture is. And these are different types of mixtures. That's what we're going to talk about now. So first you have solutions. Solutions are homogeneous mixtures in which one, the solute, is completely dissolved in another, the solvent. Solutions can be made of solids, liquids, or gases in combination. So our example here is salt water. Okay, so you have the solvent, which is water, and you add the salt, which is the solute. Okay, the salt is completely dissolved in the water, and it becomes a homogeneous mixture called a solution. Next, we have colloids. Waiting for that picture to show up. Okay, colloids are mixtures that are halfway between. Actually, I'm gonna skip this, and we're gonna go to the next slide, and then I'm gonna explain colloids. Whenever y'all are done, I'll go to the next slide, and then we'll go back. Okay, we'll go back to this in just a minute. All right, so suspension. Suspensions are heterogeneous mixtures in which particles do not dissolve and are not evenly distributed. So on one end of the mixture spectrum, we have solutions, and on the other end of it, we have suspensions. So over time, the particles in a suspension can settle out. Most suspensions are solids and liquids, but can also be two liquids or even a solid or liquid in a gas. So examples of suspensions are muddy water, where the mud or the substrate eventually settles to the bottom once the water isn't being disturbed anymore. Another example would be salad dressing, okay, where you have like an oil mixed with other liquids. Because of the different densities of the liquids, they settle out, they separate. And you guys have seen that, mixing oil and water together. That's a suspension, where you can see the physical separation where one settles to the bottom. Carbonation, like soda, is a suspension where you have carbon dioxide that's trapped in bubbles in the liquid, and eventually it separates out from the liquid. All right, so that's a suspension. So let's go back and we'll talk about what colloids are. Colloids are mixtures that are halfway between a solution and a suspension. So particles appear to be distributed, but upon closer inspection, they reveal a heterogeneous mixture. Particles are not large enough to settle. So our example here is milk. Okay, within milk, you have water and fat. All right, so you add the fat to the water to create milk. And it looks like, when you're looking at it as a whole, you don't see the fat in the water, right? But when you look at it on a molecular level, it's not distributed evenly. Okay, so the more fat you have in the milk, because it has less density, you'll see the fat tend to, the water will tend to settle towards the bottom and the fat will rise to the top. Okay. This is kind of a weird example, but like, say you have collected some breast milk. All right. So if you have, so breast milk has a lot of fat in it because growing babies need a lot of fat to help their brains develop, the DHA in it. So the fat, if you see like a container of it in a fridge, you'll see like a big layer of fat on top of the liquid underneath, okay? So that's an example of a colloid. Eventually, like it's all mixed together, but like eventually it'll settle out, okay? But typically, colloids like the milk that we drink in the store, from the store, the fat isn't large enough or the particles aren't large enough to settle, okay? So it'll still appear to be like a mixture, but upon closer inspection, it's really a heterogeneous solution or mixture. Okay. All right, so that's it for my teaching slides today. Homework is complete section 2B review questions by next Wednesday. I can't give you homework over the weekend. Monday's a holiday, so your homework is not due until Wednesday. All right, honors students, keep working on your compare and contrast essay between the atomist view with Aristotle's view. what the history of matter is. This is independent research. And that's due before class next Friday. And next, we are going to play a Kahoot. So if you have your computer, please get your computer out. And I will stop the recording. Yes, sir.
I use my phone because my computer's on dead.
1 second.